So this is the code for lesson 107's assignment, creating a standalone measuring device with the ultrasonic sensor and OLED display and a button. So here I import the necessary libraries, set up the SCL and SDA pin, set up the OLED and the OLED object, populate the initial screen. I'm calling it the distance-o-matic, giving instructions to point at target and press button to measure distance and display that. And then I'm using two state machines, one for the ultrasonic sensor, which is this setup here, and it's pretty much exactly what I did in the previous assignment for measuring the distance with the sensor. And then here is the monitor button, which is pretty much identical to what we had done in previous lessons with using a button. And it fires interrupt 1 because I'm using state machine 1, and that's what I'm monitoring in Python here, state machine 1. And then the function is to do measurements. This is the so basically the OLED changes to say measuring. I set the count, which is 4 million, which is what I'm going to send to the state machine to start counting down from. I'm doing 5 samples. I thought maybe if you were holding it, it would be good to take an average. So I'm doing an average of 5 samples. This variable is to add that to it. So then this is the loop where I basically collect that information. So I put the 4 million, and then I wait to get, which is what that first state machine for the ultrasonic sensor will return, the new count. Subtract the ping, which is the variable I populated with the get, from the count, divide it by 2, and that gives me the travel time, which I multiply that by 0.343 to get the distance for that trip, and then I add that to the dsum. I take do a little sleep. I found that if I left that out, I was getting really weird errors because the new for loop was putting before the old one was done, and it didn't seem like the pin would ever go low again, the echo pin. So this slight delay seemed to fix that. And then once I get the 5 times, I divide that total sum by the number of samples, and then display the distance and wait 5 seconds here and tell it, restart the whole loop and wait for the IRQ. So pretty straightforward, mostly with just the state machines. Obviously you needed to do some of this calculating in Python, but it seems to work pretty well as a standalone device. This is the device for lesson 107's assignment, creating a standalone unattached measuring device. So as you can see, I have the OLED, the ultrasonic sensor, and then the battery pack. I'm going to turn it on now. You can see it says distance-o-matic, point at target and press button to measure distance. So I'll bring it over here where I have a target. I'll press the button. It says measuring, and then it says 17.5 seconds. It'll pause for 5 seconds and then tell you to point at the target again. So I'll measure it again. At time it says 18.1 centimeters, which is a little unusual. We'll try again. 17.8. 18.3. I don't know. I think I have it a little crooked to the target, but 18.1. 17.8, but I can pick it up if I wanted to measure the wall. Could push the button. $378.5. I think I moved that too soon. Yeah, see, there's 383.7. I moved it. See, that's the problem. If you're not holding it steady, it gets different ones. But all in all, it works. 11.9. Back pointing at the tissue box. 12.0.